Hello everyone, today we will try to learn how to find the inverse matrix using formula. So the formula is 1 over AD minus BC, and the A and D have to change their position and the B and C have to change the sign. Okay, so this is AD minus BC is so-called determinant of the inverse matrix. If it is equal to 0, that means the inverse does not exist. So AD minus BC is actually the determinant of the matrix. It can determine whether the inverse matrix exists or not. If AD minus BC equal to 0, that means the inverse matrix cannot be determined. So the concept of the inverse matrix times with the matrix is equal to identity matrix. So actually how to derive the formula for the inverse matrix is very complicated. So I'm sure we actually don't have to know the way to actually derive the formula for inverse matrix, but you must take note that the position of the A and D must be swapped, and the sign for B and C must be changed accordingly. Okay, so this is a very important formula. Then the A is actually AD minus BC is so-called as determinant for the matrix. Alright, so we are going to use this formula 1 over AD minus BC. Okay, the A and D change their place, the B and C change their sign. First of all, we want to determine 1 times 8 minus 2 times 4. Notice that the matrix A is having the determinant 0, so the inverse does not exist. For B, AD is 3 times 4 minus 5 times 2, so is actually equivalent to 2. So matrix B is having determinant not equal to 0. So hence the inverse of the B exists. So we can find the inverse matrix. Let's find out 1 over 3 times 4 minus 5 times 2, 4, 3, right? 3, 4 become 4, 3. Negative 5 and negative 2. We have to change a sign from positive to negative. And then we just simplify the determinant 1 over 2. Okay, and then we have to times with all the elements with 1 over 2, right? So for this matrix, we are having matrix C, right? So let's see, we have 2, negative 6, 1, negative 2. So the inverse matrix is 1 over 2 times negative 2 minus negative 6 times 1. Okay, this is the determinant, and the 2 and negative 2 have to change a position, and the sign have to change, become 6 and negative 1. So we actually use a formula and we simplify to the single matrix, which is negative 1, 3, negative 1 over 2, 1. So let's do for matrix D. Okay, we have M negative 6, 1, negative 2, and the matrix D does not have inverse matrix, so we have to use a AD minus BC equal to 0. So M times negative 2 minus negative 6 equal to 0, so M is equal to 3. So when M equal to 3, the matrix D does not have inverse matrix. So let's see, if we try to solve the matrix is M times negative 2 minus negative 6, 1. So we will try to solve the inverse matrix. So we have to change the position, and then we do comparison because the inverse matrix was given. So that means the negative, okay, let's do comparison one by one. So if you compare, you times in and then do comparison, so you will get the answer M is 2, right? Okay, so that's how you solve it. So it's given that 1, 2, 3, 8 times with the A is equal to identity matrix. That means the A will be the inverse of the matrix 1, 2, 3, 8. So let's find the inverse matrix for 1, 2, 3, 8, which is equivalent to 1 over 1 times 8 minus 2 times 3, and then 8, 1, negative 2, negative 3, right? So we have to understand the concept of the matrix and the inverse. So finally, we'll simplify to the simplest form, and it seems like the matrix must be in single matrix. For each of the following matrices, determine whether the inverse matrix exists or not. So we just find the AD minus BC, 6 times 1 minus 0. So since we are not getting the 0, so it seems like the inverse matrix exists. Alright, so we can find the inverse matrix. So it's 1 over 6 times 1 minus 0, 1, 6, and the 0 still remain. We don't have to worry about 0. So the answer is 1 over 6, 0, 0, 1. That is so-called single matrix. Alright, so 2 times 2 minus 3 times 1, we'll be getting 4 minus 3, which is actually not equal to 0. So it means that this one has inverse matrix. So 1 over 2 times 2 minus 3 times 1, and then we change the position for 2 and 2, and the sign will be negative 3 and negative 1. So if we simplify, we will get the answer, which is the simplest form. Alright, so we have solved the inverse matrix. So let's see this one. For each of the following matrix, determine whether the inverse matrix exists or not. AD minus BC, negative 2 times negative 9 minus 5 times 3, we will have the answer 18 minus 15, which is 3, not equal to 0. Hence the inverse matrix exists. So we can actually find the inverse matrix, which is 1 over negative 2, negative 9 minus 5, 3, negative 9, negative 2 change the position, and 5 and 3 change the sign. We will get the answer. And how about D? We are getting 4 times 1 minus 2 times 2, which is equal to 0. Hence the inverse matrix does not exist. So we don't have to find the inverse matrix since it does not exist. So for this one, let's see. Before we determine, we try to find determinant. 5 times 3 minus 6 times 2, and then it's not equal to 0. So 3, 5, negative 6, negative 2. So we simplify to the simplest form. We will get the answer for the inverse. Okay, for this one, 1, 2, 5, minus 3, 3, and then 5 and 2 change positions, 3 and 3 change the sign. So we'll get the answer 5, negative 3, and negative 3, 2. Alright, for C, it's 1 over 4 times 2 minus a negative 2 times negative 3, right? So okay, so let's change the position for 2 and 4, and we change the sign for 2 and 3, right? So final answer is 1, 1, 3 over 2, 2. And then for D, we will have 1 over negative 2 times 7 minus negative 5 times 2, and then negative 2 and 7 change the position, and then 5 and negative 2, right? So we'll get the answer, which is negative 7 over 4, negative 5 over 4, 1 over 2, and 1 over 2. Okay, it's given that matrix G, alright, calculate the value of P. So we are given the matrix G. So let's see, we have AD minus BC, which is 2P minus 1 times 3 equal to 0. So that means 2P equal to 3, then P equal to 3 over 2. So if P equal to 3 over 2, that means it does not have inverse. For the b, we try to find the inverse 1 over 2p minus 3, and then p and 2 change the place, and then negative 1 and negative 3, and we do comparison. So we will just compare and solve the elements and find the p. So we will get the answer for the p by comparison between the inverse matrix found by us with the answer given in the question B. The inverse was given. For question number 4, we are given two matrices multiplied by each other equal to identity matrix. That means the P will be the inverse of the matrix 4, 10, 1 over 2, and 1. So let's find the inverse matrix from the 4, 10, 1 over 2, 1. So it's 4 times 1 minus 10 times half. And then we have to change the position for 1, 4. And then the negative 10 and negative half, and we simplify to the simplest form. We will get the matrix which is actually the inverse of the matrix given. So that is the answer for the matrix P. Alright, so this is a very important concept. P times P inverse equal to P inverse times P equal to identity matrix. So please bear in mind that when you have two matrices multiplied by each other, you are getting identity matrix, meaning that the other matrix will be the inverse of the matrix given. Alright, so that's all for the sharing about the inverse matrix. Till then, I shall share with you more video teaching in my next coming lesson. Bye bye and have a nice day.